so again, we've just got a ton of formulas at the top, and you're gonna have your note card for your test, so you can write all these on there. Okay, so I'm not like expecting you to memorize these. On your exam, you get a formula sheet. Huh? On your final exam?
Yeah.
Did you?
Yeah.
I misunderstood. I'm sorry. On your final exam, you get a formula sheet. I can't remember what all is on there, but it's nothing like super helpful. Right? It's like your Pythagorean identities. It's the ones that are easy to remember. So what I do is I give you guys that formula sheet early, and then like as we review anything that you have to look up in your notes to remember, like stuff like this, write it on there, so that like when you get yours for your test, you just copy all the information again. Anywho, all these formulas you'll be able to write on your note card for your test on Thursday. Yeah? Okay, so like you should have all the formulas you need for your test, because you're going to get a note card. You're going to put them all on there. You'll be super successful, and you'll be so glad you had your test, because it's going to get you a good grade before your report card. Yes. I made the test yesterday. There's a bunch of easy questions on there. It is multiple choice. Well, there's a couple questions that are not with the trig identities. Well, I said we're recording. We're wasting time, guys. All right, so we need to go through this stuff. So just like we did before, we're just going to apply those rules that they gave us at the top, okay? So for the first part, we're given that sine is 3/5, and our angle is going to be between pi/2 and pi. So where is that going to fall? We know that's going to be in quadrant 2. We want to find the exact value using the double angle formulas up here. So I think it's helpful to go ahead and find like sine, cosine, and tangent, because sometimes you have to use tangent, sometimes you don't, sometimes you do. So let's go ahead and use what they gave us to find cosine and tangent as well. So we'll draw our triangle in quadrant 2. So we know that sine is what over what? Opposite over hypotenuse. So your opposite is 3, your hypotenuse is 5. What's your missing side going to be?
4.
4 or negative 4?
Negative 4.
Why is it negative 4?
So
we're in quadrant 2. Awesome. So what is cosine going to be here? Yeah.
Okay.
And what would tangent be here, just in case we need it?
Yes. 3/4. 3 is negative 4.
Negative 3/4? Is that okay? Questions on any of that? All right. So we are going to use our rules up top to find sine of 2 theta. So sine of 2 theta says that you do 2 times sine of theta times cosine of theta. So we'll do 2 times sine of theta. And what was sine of theta? Sine of theta was 3/5. That's what they gave you to start with. So we're doing 2 times that. And then we got to multiply by cosine theta as well, because that's part of our rule. And what did we find that cosine theta was? Negative 4/5. Is that all right? Okay. So we're going to have 2 times negative 12/25. And what's 2 times negative 12? So negative 24/25. That's our final answer, and we're done. Is that okay? That's it. Yeah, not too bad, right? So we need to find cosine of 2 theta as well. So we're using that rule up here. So there's like 3 rules that you can use. All 3 rules are going to give you the exact same answer, so pick whichever one's easier. They're all kind of the same. So I'm just going to use the first one. Is that okay with y'all? All right, so we'll do cosine squared minus sine squared so what was cosine of theta? So we've got negative 4/5 squared. And what was sine of theta? It's 3/5, and we're going to square that. So negative 4/5 squared is going to be 16/25 squared. Or not squared, we already squared it, sorry. And then 3/5 squared is going to be 9/25. So 7/25. Final answer. So if we use the other formulas, you would get the same answer. So So I'm going to show you that. You don't have to write this down if you don't want to. But if we use the 1 minus 2 times sine squared, 1 minus 2 sine squared theta, we would have 1 minus 2 times 3 over 5 squared. And when you work that all out, you still get 7 over 25. And you could use the other formula, which was 2 cosine squared theta minus 1. So we would do 2 times negative 4 over 5 squared minus 1, and you still get 7 over 25. So again, you can use either of those, whichever's going to work best for you. Questions? Alright, so the last part that we need to find there is tangent of 2 theta. So we'll be using that rule up top, where it says tangent of 2 theta equals all that stuff. So I'm just going to copy that down again so we have it closer to where we're looking. So it's going to be 2 tangent theta over 1 minus tangent squared theta. And we found tangent theta, so it's going to be super easy to just plug in. What was tangent theta for us? Negative 3/4. Then we're going to have 1 minus tangent squared, so negative 3 over 4 squared. So up top, you're going to get negative 3 over 2. And then on the bottom, when you work all this out, you get 7 over 16. So I'm going to multiply by 16 over 7. And that's going to give us negative 24 over 7 for our final answer there. It's kind of hard to read my writing here. Questions? Yeah.
Would it be positive 24 over 7? Because after you square it, you still get 1 minus 9 over 16.
Up top is negative. Because 2 times 3 is 6, and 6 over 4 reduces to 3 over 2. Questions? Anything else? I'm just trying to go through this quickly so that we can get through it all. You can type this stuff in your calculator if you need the math there. Yes, you'll have your calculator on the test. So really, y'all, you should do very well on this test. Are we okay with the double angle formulas?
Yeah.
Yeah, that's all those. So again, you're going to get your note card, put them on there. Your half angle formulas are going to work the same way, essentially. So there they are. So we're going to find the exact value of these using our formulas. So cosine of 15. What quadrant is that going to fall in?
1.
Quadrant 1, right? So what is cosine in quadrant 1? Is it positive or negative? Positive. So we know that when we do this, we're going to use the positive square root. If it was in a quadrant where cosine is negative, then we would use the negative square root for our answer. Is that okay? I think it's in the instructions. It tells you which one to use. I think so. I think so. You should be able to tell based on how it's set up. But I think it tells you, in the instructions, use half angle formulas, use whatever. Yeah. I'll double check on that though. Remind me when we're done with notes. So we know that 15, they did sum angle divided by 2, right? So sum angle divided by 2 gave us 15. So what was that angle? 30. So that's the angle that we're going to use when we plug into our formulas here. Is that okay? Because inside your formula, it's just the alpha. It's not the alpha over 2. So we're going to say the alpha is 30 degrees for us. So we're doing cosine, and we said that in quadrant 1, cosine was going to be positive. So we're going to do positive square root of 1 plus cosine of alpha, which for us is 30, over 2. And these answers are kind of messy because you've got square roots under square roots. So we're just going to try to get as exact as we can. What is cosine of 30? So we got 1 plus square root 3 over 2, all over 2. So then if we get common denominators and like add your numerator there, you're going to have 2 plus square root 3 all over 2. Or, is that correct? No. Hold on. I went too far. How can I fix this? So it was like this over 2 again. I ran out of room. Does that make sense? So you had like the 2 plus square root 3 over 2 again. I goofed here. I goofed. I'm sorry. This should look more like 2 plus root 3 over 2 all over 2. Is that better? And so then that's just 2 plus root 3 over 4. And then we can take the square root of the numerator and denominator separately. So we'll just leave square root 2 plus square root 3 on the top, but then we can take the square root of 4 and we'll get 2 there. So that's as far as we'll go with our answer on this one. Questions? So looking at number 2, same idea. So we've got sine of negative 15 this time. What quadrant is that going to fall in? 4. We know it's going to be in quadrant 4. So do y'all remember those even and odd rules that we had for trig functions? Like if you have a negative angle, you can pull it out sometimes. So for sine, we can pull that out. So you have like negative sine of 15, and it's the same thing. So again, we had some angle divided by 2 gave us negative 15. So negative 30 is going to be our angle this time.
I know it doesn't really matter, but how do you know it'd be in quadrant 4, not 3?
Because the angle measure is only 15 degrees. So if you go backwards 15 degrees, that's going to fall in.
Why does it matter what?
So we know what sine it is. So what sine is sine going to be in quadrant 4? Positive or negative? Negative. So then when we go do our formula up here, we're going to do negative square root of whatever. So we'll have negative square root of all the stuff inside. Is that okay? So we'll have 1 minus cosine of alpha, which for us we're using 30. Or negative 30, I guess. Over 2. And so what is cosine at negative 30? Square root 3 over 2, so we have negative big square root of 1 minus square root 3 over 2 all over 2. And so again, we could write this one as, I'll go this way, negative 2 minus root 3 over, all this is over 2 again. So it's going to end up simplifying the same sort of way that it did over here. So we'll have negative big root 2 minus root 3 over 4. Is it minus or plus there? Over 2. So we've got negative square root 2 minus square root 3 all over 2. Okay. Questions? When you have it's divided by 2, you can divide it by 2 again. That's like just dividing by 4 once. So you would like multiply by 1. Yeah, so that's that. We're almost done. So the next section, they're giving you that cosine of theta is negative 3 over 5. They're telling you that theta is going to fall between pi and 3 pi over 2. So what quadrant is that in? Quadrant 3. And so we've got to find sine of theta over 2, cosine of theta over 2, and tangent of theta over 2. So before we do any of that, we're going to do that triangle and find sine of theta and tangent of theta so we can use it for the rest of them later. So again, we know this is going to be in quadrant 3. And they told us that cosine was negative 3 over 5, so that's your adjacent and your hypotenuse. So our adjacent is going to be negative 3, our hypotenuse is 5, so what's our other missing side? And is it positive 4 or negative 4? Negative 4, because we're in quadrant 3, so everything's negative there. So what would sine of theta be? Negative 4 over 5. What would tangent of theta be? It's going to be 4 over 3. Alright, so real quick, we know that our original angle, theta, is in quadrant 3 because it said pi was less than, theta is less than 3 pi over 2. When we go to do all of these things, we're chopping that angle in half, right? So that's going to change what quadrant we fall in. Do you agree? So we've got to divide all this stuff by 2 because that's what we're doing with theta. So that's going to have us between pi over 2 and 3 pi over 4. So our new angle, theta over 2, is going to fall in quadrant 2. So that's going to help us with our signs there. Is that okay? If you aren't quite sure how to figure out where this is, what could you do? Do we know? So, y'all, well, some of us remember because we were here. If you have like your unit circle or whatever, this would be 0, and then over here is pi, so that's 3.14, right? Pi over 2 is up here. Do y'all remember like what decimal that is? 1.57? I don't know what it is. Whatever it is a decimal. You could like get those as decimals and see what it falls in between. Does that make sense? So that's going to put us in there. So that's what I would do if I wasn't quite sure. So we know that our angle theta over 2 is going to fall in quadrant 2. That's going to help us pick our sines for the rest of the stuff. So for the first one, we're doing sine of theta over 2. So we'll be pulling that formula from the front. And in quadrant 2, is sine positive or negative? Positive. So we'll be doing the positive square root. So we'll have square root of 1 minus cosine of alpha over 2. Or I guess really instead of alpha, we should have a theta there. I'll do that. We'll write theta there. Be proper. Since theta was all of our stuff. So what was cosine of theta? Negative 3 over 5, all over 2. So when we do 1 minus 3 over 5, we get 8 over 5. And that's all over 2. So then that's like 8 over 5 times 1 over 2. So that's the square root of 8 over 10. Which we could simplify that fraction inside and make it 4 over 5. And then square root top and bottom, the fraction lines. So that's probably how you'll see your answer on the test. They'll go ahead and rationalize it and everything. If it was me, I would probably stop a lot sooner, but I think I know how to take it all the way. So, questions there? All right, so we're going to do the same thing for cosine. So our rule for cosine is, I'm going to copy it because it's on the front, so we'll have to flip back and forth. Square root 1 plus cosine of alpha over 2. So for us, again, we're in quadrant 2 for theta over 2. So what sign is cosine in quadrant 2? Negative. So we'll be doing negative square root 1 plus cosine theta over 2. So we'll have negative square root 1 plus negative 3 over 5 all over 2. When we do 1 plus 3 over 5, we get 2 over 5. So we've got 2 over 5 all over 2. And then when you do that, so that's like 2 over 5 times 1/2. The 2's cancel. We're going to have negative square root of 1 over 5. And so we can take the square root of every numerator and denominator separately and then rationalize that. So we'll have negative 1 over root 5 or negative root 5 over 5. And that would be your final answer there. Questions? Alrighty, so then the last one we're going to do is for tangent. So I think there's 2 for tangent, correct? Yes. So again, either one's going to get you where you need to go. I would pick the easiest one. And to me, this looks a bit easier than all of this. So we're going to go with that one. Is that okay? We're doing the 1 minus cosine over sine. You could? Mm-hmm. I think this one's actually the easiest one. So, what is cosine of theta? Negative 3 over 5. And what was sine of theta? Negative 4 over 5. So up top we had 1 minus negative 3 over 5. That's going to give us 8 over 5. And then I'm going to multiply by negative 5 over 4 since we're dividing by negative 4 over 5. And the 5's are going to cancel. Then you've got 8 divided by negative 4. What's that going to give you? Negative 2. Is that all right? Questions?